But at TMAC, we do training and consulting, and we really appreciate the partnership with SAMA because it's given us an opportunity to do in the area of process improvement, the lean manufacturing certification program, which is a 5-day course. And then now the even more popular manufacturing supervisor certification program that a number of the local manufacturers have taken advantage of for those up and coming supervisors. We also teach some internal audit classes that supports the quality systems, and we've got a lot of resources around cybersecurity due to our connection with NIST, which has written some of the DFARS requirements for how to meet the 800-171 requirements to supply military, et cetera, federal programs. But in any event, we're here really to talk about automation. And the reason we're here, or we were asked to do a program, somewhat of a repeat that we did earlier in the spring, which was Should I Hire a Robot? And Mike did a portion of that presentation, which is going to be our key speaker here. And it really gave some insights into how to adopt and what are some strategies around when you dip your toe into the automation activities. So his presentation, so let me click and give you a little more introduction. I think that I'm going to release my camera so Mike can put his on. But Mike's 25 years of manufacturing experience, 18 years at PSI, and he also tells robot jokes. So, interspersed within our presentation, we'll let Mike maybe sneak a few in. So, Mike, you go ahead. If you click your webcam, and you ought to be able to grab hold of the center screen.
Oh, I'm sorry. You caught me doing my taxes. I hope there's a accountant out there. You really need some help. But thank you, Bill. I really appreciate the kind words. And Bill's absolutely right. And when I look at the audience, I look at the list of people we have here with us today. My relationship with you guys has always been through SAMA, San Antonio Manufacturers Association. I enjoyed first time I went to an event, I said, I've got to participate in this, and got the opportunity to start with the programs, chaired it for 1 year, and still seeing the thing that SAMA is doing, and it's really remarkable. So thank you. My hat's off to all you guys that are participating in the first 2021 virtual reality. Wow, it's like a rock and roll show, isn't it? It's really, really good. So I hope we can entertain you. I hope we can educate you, and we'll go from there. Bill, anything else you want to highlight before we start?
No, if anyone has any questions, feel free to interject. I think Mike said he'd take them, or if you want to send it through chat, I'll queue them up for him.
Okay. All right. We'll see if we can get this technology to work. I'm going to go to the third cam right there, and we'll start the presentation. But once again, this is just another manufacturer's insight. I'm Mike. I'm not a true manufacturer. I always say that because I spent some time in the service, and then I was a PE coach for a while, and then I spent 7 years in semiconductor industry, and that's when I got my first taste of manufacturing. And it was exciting, as expected. But like Bill said, I've been here 18 years, and I've seen the development over the years since we've been here, and our journey to automation. It's just another story like many other people. So I hope some of you are having some thoughts whether you should or should not deploy automation or robotics. I'll call it AR for short, for automation and robotics. But I hope we can help you. I hope we can answer some of those questions and see that some of the things you're thinking, is the same thing that everybody else is thinking. It's like that thing about the question, not being asked. So if that's the case, we'll move on. The agenda today, we're going to talk about PSI, who we are, the PSI growth, and really the why. What was it that was so important for us to get into this robot journey, and was it a good thing? Then we're talking about the how. Our relationship with TMAC and lean manufacturing through SAMA. And then I've got to tell you the story of meeting my educator and my integrator and the very important points of that. I have a slide that I'd like to discuss. I call it the 4 points of ponder, something to think about. I'm not saying these are hard, fast rules, but they're little golden nuggets that's helped me through my journey. And I tell you, I've kept my conversations very specific and very simple. When I think of lean manufacturing, I think of reducing waste. That's basically it. And I use downtime, defects, overproduction, weighting, non-value added, transportation, motion, employee, underutilization. Same thing every day. When I think about robotics, I'm going to share those 4 points that I use every time. And I try not to get away from that. It helps with a very, very clear vision to the people that you serve out there. I will share some examples of automation that we have in the plant. And as Bill said, we did this earlier in the spring. And the funny thing was I had to go out in the factory to look for different examples of automation. And like, how long have we been doing automation? Then I forgot that our company name, we are the Automatic Tire Inflation System. We've been doing automation for 28 years. So I thought that was kind of ironic. Then I'm going to share with you some lessons we learned from our first robot. And on the last slide, I'll talk about what I have some talking points, some more key things that I think will help you as a guide. And at the end, we hope to open up some questions and answers. And if there's nothing else more, we will proceed. Anybody leave yet, Bill? They still there?
I'm keeping it. I locked the doors. You're good.
A good move. Okay. Who we are, Pressure Systems International out of San Antonio, Texas. We are the Automatic Tire Inflation System. You've known us for many years, and the good news is we've expanded. We've been restricted to the trailer for over years, a Class A trailer, but we've incorporated 2 more parts of our portfolio. One would be tire view, so we can actually tell you the pressure and the temperature of a tire on the tractor. Same thing on your boat trailer, things of that sort. And we can actually send this data. If you're driving a truck in San Antonio, but your fleet maintenance is in Dallas, they can actually call you up and say, hey, you're about to have an issue with your tire. So as I said again, automatic tire inflation for trailers, that's our bread and butter. That's who we are. We invented ATIS about 28 years ago. We're out of Corpus Christi. That's the owners, the Berries, who own Bay Limited. And we've equipped almost to date, almost 2 million trailers, 1.8 to be more specific. And what we do is we have the technology to recognize an underinflated tire on a Class 8 trailer and inflate that tire to your desired pressure while you're running down the highway. So as that tire is spinning, we're actually putting air in it. Makes you go, think about that one. San Antonio, I love it. This is our headquarters and our assembly operation. We've got about 65 peeps out there doing production sales. Our products are used worldwide. You can see us locally on HEB, FedEx, Amazon, UPS trailers, and that's not counting the military. All right, enough of that. I like to say, as far as the assembly plant, we're very much like everyone else. When I visit my buddies out there, they do assembly just like us. But I had to say, we enjoyed that week, 5 days a week. We really crank it. We crank it. It's putting it out. It's 6 typical cells with some other subcells that we use hand tools, electric tooling, pneumatic presses, just like everybody else. And of course, we had 3 robots, and there's some journeys coming on that we may expand on that. But on a daily basis, 6,000 air hoses, 600 control boxes, 3,000 axle stators. These are just sub-assemblies that we produce on a daily basis. So indeed, we crank it. And cranking it causes some problems. So the backstory, the trailer demand, 2003, when I first arrived, we were doing about 100 trailers a day. All right. Then it started to increase and people started to buy into the product and believe it. And other things were getting market share and all that stuff you do in business. Well, we started seeing a little jump, and then we started getting a little nervous. We think we're going to really make some significant jumps from 24,000 to 40,000 trailers a year. And we quickly realized we needed some help. So we reached out to SAMA once again and say, what do we have out there that can assist PSI in this next venture? And it was my boss, Steve Ottoman, and our IT department, Catherine Musgrave, that went through the first class, the lean manufacturing class, came back and had some ideas and said, Mike, you need to go. Once I went, it opened up to everything to me. It was like really a lot of confirmation of everything you think you know about robotics or manufacturing, I should say, or really cells and moving product. And it just made it so clear. So we, once again, thanks to SAMA and TMAC for that. We're looking good, and then we hit the downturn. Fortunately, we still did well. Transportation didn't shut down. So then once we got past 2009, like everybody else, we was like, oh boy, look out, here it comes. So now we knew we were going to be up to 500 trailers a day in 2010, and it really hasn't slowed down. Even COVID, we did well. And really, how we're going to maintain this? That was the big question and the scare, you know. Do we want to go into overtime? We use it every now and then, but you know it's not sustainable. It could be a solution, a temporary solution, but when you try to do a long range, it just wears everybody out. Everybody's exhausted. You probably saw it through some of the COVID things. Alternate shifts, oh boy, always my last resort. We tried a night shift, but as you know, it's hard to get the leadership, the security, a lot of things just change. It changes who you are. So for me to get to the next batch of 40, 60,000 trailers, I wasn't going to consider overtime. Increasing tool capacity. The good news is we had a lot of our old tool sets that we brought back, and so we could safely run them, and that gave me that extra throughput. And then you can do all the little things you know about. You can increase the labor. You can squeeze that lean lemon, try to get as much out of your factory as possible. You increase the customer's lead time. And the gentleman before us at the 10 o'clock was talking about outsourcing. That was an option. Once again, this is 2010. Do we send this off to have it be done somewhere else? So those were all typical standard solutions to how to increase your throughput in a factory. But the decision was made to go the TMAC route. And before we made any other huge decisions, which we all want to, and this is probably what happens in most developments or most sites, somebody comes up with the idea, we need a robot. Everybody's excited. Where are we going to put it? Well, let's put it over here. And no. Let's. I think it should go over here. Hey, let's do this automation thing. But like, whoa, stop. It's so important, and that's what TMAC will teach you to the Lean class. You've got to do the value stream mapping. That is really putting your entire operation on the wall, very visual, from getting the customer sale all the way to being paid, 30, 60 days is very important. Where does everything go? How does everything flow through your factory? Because there would be three of you that saying, we should start here, and the other two are saying, we should start here. But when you do the value stream mapping, everybody's in agreement. And what it helps you do is you start seeing those little pockets of waste, those pockets of stuff stacking up. And then now you can identify the waste, then you can start to remove it or reduce it. Some people say, well, you should always reduce waste or remove it. But I'm dealing with human elements, and they like their own little cells, and they have the tendency to bring things back. And I truly understand that. But once you do the value stream mapping, you do the lean, you remove the waste, you just watch it flow. It'll go through your factory like you wouldn't believe it. So we were doing that. Things are great. So what was the next step? I mean, we cranked it. We're cranking it again, and we've done well, but it's still, we needed some more help. So the concept was to take our current tooling and understand Pressure Systems International, kind of unique. It's kind of fun. The fact that when we started, there was no such thing as a hose bender or a T-tester. I couldn't call Granger and order this and order that. We had to create our own tooling. So we had some good old boys down in Mathis that made our tools. We had some great engineering support that made the tools work. But that was just it. They were just the good old boy tools. And we started having some issues with consistency in the parts. They were just getting old. So we really needed an upgrade, and we needed safety incorporated, the laser curtains and things of that sort. And then we started thinking about, maybe we should look at some semi-automation, because we would basically load, push a button, or one button, I should say, didn't have the safety factor, didn't have the hands-free stuff, and load and unload. And that was all we did all day. But there's some other options to get a little faster. And the tooling was getting old, and we weren't having the consistency in the parts. So the next big question was, now is it time for PSI to look into automation or robotics? And that's what you're here to find out. And I will share that with you. So when I was at Philips Semiconductors, I had the luxury of reading this book, The Goal by Mr. Goldratt. And I highly suggest it. If you are the lean champion in your organization, or if you're just a little curious about the way a plant should run, the theory of constraints, and this thing called Herbie. I'm not talking about the Volkswagen bug from Walt Disney. I'm talking to everybody has a Herbie in their plant, and that's this bottleneck that just slows you down, that's killing you. And understand the bottleneck's always going to move. You're always going to have Herbie, but you got to learn how to manage it. And this book helped me tremendously, and I highly recommend you read this book. And it's done more of a story of a guy like you and I, a factory manager that's struggling, thinks he's doing well, but he's kidding himself. And he runs into his mentor and starts asking those key questions. And he goes, "Oh, we have a robot. We're awesome, man. Our robot's fantastic." And the guy's like, "Well, so you're making more money with the robot?" And the guy, "Well, are you faster with the robot?" Maybe in this cell, but as you know, you start running one robot and somebody just stacks up there. So things you got to consider. But the 4 points I'm always talking about is the life cycle of your product. If you want to go into automation, how long do you think you can be building this gadget? If you have this subassembly, you think, you know what, we need automation. That's your sales and marketing guys will always come up with something different. And they're like, well, we want to change it. I think maybe the rule of thumb is, and somebody could probably help me out there, but you probably want to stick, if you're going to go to automation, you probably need to do that same assembly for the next 10 years because you're going to put a lot of money into automation. It's a little bit different. And that's when it's a relief we get from robots. And we'll talk about that in a second. But the idea with automation and semi-automation, you only want to do it for 3 more reasons. And that is, when I look at these points here or over here, I'm sorry, there they are. Can you lower your inventory and your WIP? And you'll find out what you do. The old style, when PSI first started, we had a typical cell. We had 8 to 10, 15 people in a cell, and we did this huge batches. I mean, 200 to 400 hoses would move in a batch. 30 to 50 control boxes would move in a batch. And there was so much inventory. There was so much WIP. There was so much handling. We just weren't really going anywhere. We looked busy, but it just wasn't flowing. It wasn't going anywhere. And then when we were done, we had we'd go put it in inventory, and then we need it. You had to sign it out and bring it out in inventory, and then when we package it. So we had inventory everywhere. So if you want to get into automation and use that robot, start thinking about, can I lower my inventory and my WIP? If you can, it may be something really good for you. Secondly, decreasing your operating costs. I think on average, I say an employee costs us about 40 to 50 grand a year. You can start looking at the ROIs and things of that sort, but the overall, a robot doesn't take a lunch break, which was not really true because I forgot to tell you, but do you know how a robot spends his lunch hour? You don't know, do you? He grabs a quick bite and he munches on some microchips. Ta-da! Okay. All right. We'll move on.
Pretty good.
It's a tough crowd.
It is. They're avatars.
Yeah. Second one is, like I said, decrease your operating costs. It doesn't take vacation, doesn't need PTO, it doesn't get sick, and some other things. And then once again, what we all love is this automation going to increase my throughput? It's funny. I have a new project that we're going to go wrap up with ITM this week, and we're going to do the design review on a through-T tester, which we have 3 of them running right now, and we need more throughput. So we're going to double up on that one through-T tester. It takes an operator about 10 seconds to run an operation. So we're going to run those 2 tests at the same time. And then we put a counter on it so we can actually see the difference between the 2 tool sets, how fast we're actually producing compared to the other tool sets, because that's going to tell me everything about my throughput. Am I kidding myself, or is this really going to crank out a lot faster than I think I am? And it's good. So the idea was, we're thinking about putting a robot on it. It's kind of cool. Instead of having the operator load and unload, we could use a robot. But the big question is, it looks good, it looks fancy, but person is probably faster than that robot. So I have to really consider that. I have to take that in play. Am I really going to get throughput better than a person just to have a robot? And it's not always the case. There's other reasons why you would, and we'll talk about those things later. All right, any questions? We good? Rocking and rolling? All righty. Okay, the partnership. This is what changed us tremendously. Once again, the story is, remember, I'm not a manufacturer. I was a PE coach. I struggled with a lot of things, but I just had this hunch about building this stuff, and sometimes seemed different. But once again, through SAMA, I went over to the St. Fellows College, and Toyota had a lab there, sponsored by St. Fellows College, and they had a robotics lab and automation lab, and they're teaching young students between junior and senior year. You guys know all the stories about the academies. And I was thinking, this is what I need for PSI. This is what I need for my employees. So I was talking to Dr. Song, professor there, and she goes, "Nope, this is just for Toyota kids at the time, and there's a Mac prerequisite." I was like, "Oh boy, that's not us. That could be some problems." I said, "Dr. Song, do me a favor. Can you come to my plant, look at my new tool sets, my PLCs, everything else, and help me teach these guys how to maintain this equipment? Could you help me?" She said, "Matter of fact, yes, we've done that before." And she brought her professors over. They looked at our tool sets and they created a 6-month curriculum. And before I knew it, they had everything we needed. And matter of fact, it was so exciting about this was with Colin and Raquel, once again from Allen College, as you guys know them. They're called the corporate college, which means they were going to make a flexible schedule. So my employees could not only work at PSI, but still go to this training. And it was just amazing. And we sent 5 of our peeps. All of them have been promoted to higher positions right now. Matter of fact, John, who just knocked on my door, is my technician that went there, and he's repairing a crimper. The crimper would have cost me $1,500 easily sitting out, and he's out there doing it himself. And these are the things he learned from these academies through training through SAMA and through the Alamo colleges. But that was a big part, the education, because when you get into automation and you get into robotics, will help you 110% if you can do it in-house. The hardest thing is reaching out to the integrators and us outsourcing that labor, and it'll eat you up. You all know that. There's some good people out there, but it's one of those things that you can do it in-house. It's great. So what do? We created our own 3D printers. A lot of our all maintenance and everything is done in-house. Our design of our equipment is done in-house. But the key is the second part, which is a great integrator. That is someone to help you put your thoughts on paper, how you envision that equipment, that what you want to run, and they start bringing things, making it reality. Like, Mike, this is going to work. This is not going to work. This is how we're going to do it. And we had a partnership through John Dewey, through SAMA, once again with ITM, Innovation Technology Machinery. And I'll get a little bit more in a second, but that was a big step for us. We went through lean, did all these things, and then we had to find those partners, and that was incredible. So let's talk about those partners a little bit more specifically. And I think I alluded to a lot of it, but the Educator was a corporate college which created the 6-month curriculum. And it was fun part about it was, here's little old PSI, and Dr. Song, or I think it was Colin, said, "Mike, would you mind, there's going to be other people participating in this, HEB, Caterpillar." I'm like, these are the big guys. Yeah, I would love my guys to be in the same classroom with these other people. And like I said, it was a home run. And we're still, someday we'll get back to the advanced training when we get past this COVID and things of that sort. But the flexible training schedules, all 5 students have once again advanced. It's really good stuff. It definitely added value to our whole endeavor going into automation robotics. Without it, I would have been in a world of hurt. Second thing is ITM, which is the integrator, one that helps you put everything together. It was, and the key is, I'm going to show you 2 different robot systems. One we've been running for 5 years, and the other one we've been running 1.5 years. Still, 1.5 years later, we're working on bugs. We're working on wiring problems, things of that sort. Because knucklehead here went a different route with a different integrator. Don't forget to dance with the one that brung you. And I've learned this from HEB also. I think it was when their maintenance guys at a SAM event was talking about, they go out and they buy a lot of extra equipment. And I hope I'm not saying anything wrong, but they ran into those issues when they buy all this other equipment. It's not like equipment. You start driving your maintenance guys crazy. And what do? You start increasing your WIP of all these extra parts and things of this sort. So try to keep like tools. Well, the same thing with your integrator. Your integrator has to be the same person, which works best for us all the way through this endeavor. But experience, how long have they been in business? You can go and see, how are they doing in the industry? Are they well known in the industry? Are they a stable company? How many employees do they have? Because the hard part, when I went with the second integrator, there's about 4 or 5 people there, and they just didn't have the time and effort I needed personally to help me through this first endeavor, this second group of robots, and it was a nightmare. Are they similar with different applications? Can they do what they say they're going to do? Capabilities, once again, the in-house staff, what are their software advantages, things of that sort, as far as packaging and actually assisting and coming back to my plant and helping me? Can they reach out for the phone call or a text? Those things are very, very important. Another key point is, ITM is in Shirts. It's only about 25-minute drive. And same thing, when we moved this plant from PSI about 4 years ago, and we moved the entire plant in less than 24 hours. In 24 hours, we shut down one location, we're operational in the other. And the reason why we're able to do that, because we're just right around the corner. Proximity, very close. Same thing with your support from your integrator. You're hopefully close. You can go over there when you need to. Like I said, this Friday, not really interrupting, we're going to take a little trip, go to ITM and visit them about the current tool sets that we're working on. But that's really helps me a lot to go over and see it. Another thing is the understanding. Do they understand my business? And that's another thing that, Lean, with TMAC, they came in, Jim Cogwell and Bill and his group, and they came in, they understood PSI and they understood where we're needed. But that integrator, whoops, this is what happens when you're not moving around very much. Okay. That was my automatic lights. That's the thing about automation, huh? And just remember, you get what you pay for. I'll tell you, ITM is not cheap. They're expensive, but they're worth every penny. So that's kind of a key point. You got to really work on the education side and work on the integrator. And the joke about the integrator is pretty simple. Is how many robots does it take to screw in a light bulb? One to hold the ladder. Well, the rest depends on your integrator. So it can be very inexpensive. It can be very expensive. Once again, based on your integrator. All right, so let's see. Okay, I'm going to go, we're getting close. We're going through it, so I'm going to do a quick review. Hope this works. What we've been talking about. But we talked about the PSI has concern about its growth, which is a good thing. It's a good problem to have. And we thought about the standard solutions that everybody does. Do I go into shifts? Do I go into overtime? How am I going to actually deploy this? We reached out through SAMA, through TMAC, and we started our lean journey. We mapped it. It was the first thing we wanted to do. We identified the waste, we removed that waste, and you started to see the flow through your factory. We considered doing a tooling upgrade, and I forgot to tell you that almost every tool has been upgraded through ITM, which now has a safety curtain, which is huge. We've had our events. The throughput's much faster. It's more consistent in the parts. It's easier to exchange nest and things of that sort. Just made everything very workable. All right, it's very, very important. We talked about the 4 points to consider that you need to ponder, that being look at the life cycle of your tooling before you get into automation, because it's very, very expensive. And think about automation also, I think it's fair to say when you go into automation, people think, oh, we're going to reduce people. It's not about that. It's not about that at all. Those people that we've had, no one's lost their position to that robot. We either moved them to another position or re-educated them to run the robot. And where else can you say that I can hire a temp today, bring him in, and within 2 hours they're running the robot? So you can forget that foolishness about robots replacing people. It can in some thing, but it's just not the point. But the other points to ponder is, once again, read that book, The Goal. There's a video out there if you can find it. It's awesome. It tells us a little short story. But you got to make sure, am I going to lower my inventory, my WIP? Am I going to lower my operation expense? And am I going to increase my throughput? If you can do a couple of those things, automation, robotics may be for you. Okay. Secondly, is get a hold of that educator, so you can educate these people out here, get them prepared for that tool sets. You can do everything in-house, and you'll be much better off. And then find that perfect partner of your integrator. All right. I think at this time you've been waiting for, we're going to go review some of our tool sets. But before we review our tool sets, safety is very important. Safety is number one. So we're going to run out to the factory floor and watch a couple tools. Okay, you ready to go? Let's go. All right, let's see what we got here. This is a hose spinner. Now, once again, remember, we used to do everything by hand. And you imagine placing this tool and then literally bend it around an anvil. And when you're doing, at that time, we're doing 24 or 1200 a day, you got the old tennis elbow. And everything improvement we make, and once again, is based on ergonomics. You got to remember that, keeping everything in the windshield, so you don't get your people hurt. So this is the newest version. This is about the 4th version of this hose bender. And we actually had to take this tubing and 180-degree bend so it works on the outside part of the tire. But the problem was we kept cracking this tubing, and it was actually Cox Manufacturing that gave us the idea. Once again, a SAMA partner, they came here and said, "Hey, Mike, there's probably another way to do that, so you're putting less stress on that tube," which is true because we were basically pulling it over an anvil and stretching it, and we did well, but it's still we run in these times of cracking some tubes. So what did we do? We got with ITM. This is our problem. They came up with a solution. This is our last integration of doing that, which is actually going to roll it. Less stress on the tube, and you can see it's an automatic, semi-automatic, I should say. Still going to take operator intervention. He's going to run this tool. Pretty good speed there, and you can see everything's in a cage. So he's going to basically go through this little slot, safety first, and then he has to push button to start that. And that's something we're going to talk about later, activation. That's where it can kind of drive you nuts. And there's some advantages there. There's something you can do about that because those seconds matter. Yes, sir.
I'm just going to jump in there. If in the audience, if you did not get that video, you can click up on the upper right corner. There's a little refresh. Sometimes videos don't come through, so click up there, and if it didn't come through the first time, maybe you can get it to go that way.
You want me? Okay. So they're at home and they need to refresh. You want me to try to refresh mine?
No, you're fine. It's just the audience can make it play again.
Okay. Give them a couple seconds. I'll play it again. Give you a couple. I'm going to give you about 5 seconds here, and then have a sip of coffee, and then we'll hit it again. Is the sound and everything, is it coming out okay?
Yeah, it sounds good. There's just on the third screen up in the very corner, you can hit refresh, and that should get things to happen for you if it didn't. Because sometimes there's a gap in the internet, or you can have it won't
Very
go.
good. All right. So once again, I'll play the hose bender for you one more time. We had the function to actually, Europe changed the way they wanted the bent, and we actually changed that by switching a button. And then they changed it again, so we had to build a whole new tool. But that's one again. That's another example of here we are, going to automation. Europe was on a downturn. Now they're up like crazy, and they say, "Oh, by the way, can you change the bend of that hose?" Like, "Oh, we just spent like 16 grand on this thing, and now you want me to change it?" That's when you have to be careful about getting too deep into automation. But it seemed to work out for us. So let's visit a couple more tools. This is the telescope press. And once again, I'm sorry, it's hard to really grasp everything, but this is a 1T. We're going to build 3,000 of these a day. And what's going to happen, and this is a brand new set. So when you watch her run, she's running very cautiously because we've made some changes. Once again, if you look at the tool set, you can see, I should try my laser curtain, but my laser pointer, but it's in a box. At the upper right, you'll see the yellow SICK laser, which actually puts a beam across the entire box. And if the operator tries to break that beam, the tool won't fire, or it'll actually go back into a safe position. And then what we're going to do here for the first time is we're actually going to load the part. Once we when we break that beam, coming back out with my hand, the tool is going to fire automatically. And we reduce the stroke, so it's not as violent. Now, if you look to the right, I'm going to try my pointer. I apologize. Let's see if this is going to happen for you. If you look right here, there's a push button, which we've been using, push, push, push. But down here, there's a selector switch right here. And that's selected between auto and manual. So if she selects the the auto, once she loads the part into position, pulls her hand back, this laser stick will say, "Oh, you're good to go," and the machine will automatically press. And that helps tremendously. A second here and a second there. So let me get rid of my laser, and let's watch it one more time. It's gonna load. Automatic press. She did not go to the button. Once again, as far as the semi-automation, that's helped us tremendously, and we duplicated this tool. And once again, it's all about the throughput. I think I have a slide here I need to share with you. This was another thing that changed us tremendously. And the reason being, back in the day, we had this thing called a control box, and we still have it. And it's got a regulator in there. That's how you control the pressure to your tire. This is a newer version of the manifold or control box. And the old days, the operators had to sit there and say, "Okay, I'm building 600 of these a day. What pressure am I setting this at today? Because we have 15 different variations of the pressure. You could be at 85 PSI, 105. So the operator had to remember how to set it. And it's very tedious when you're changing throughout the day and you're doing 100 at 85, then you switch to 25 at 95 and another 3 at 103. You can see how that can make a lot of room for error. And the operator had to literally take this cap, loosen the cap, crank it down with ergonomic problems, cranking that system, that regulator down, cranking it back up and dialing it in with watching a digital gauge, snapping the cap and ready to test. So what we did was, once again, this is all in-house. We created this schedule right here that tells the operators what are they going to be building for the day and what's running at the time, how much whip is actually there, how many parts are waiting to be tested. And then we have 8 bays right here, 8 testers. There's 4 here and there's 4 on the other side. I have one individual running all 8. And the reason why that happens because the automation is we're going to load the box, as I should say, load the other box. We're going to start the process with an RFID ring. They're wearing like a little Superman ring. When they go to read the RFID, it starts the whole process. There's no discussion. There's nothing about what am I doing right, what am I doing wrong. The data automatically loads, and you'll see this is very slimmer. I'm going to go back to my cam to make sure I'm showing this properly. This is a little robot arm with a stepping motor that we made in the lab. Turns, and it turns very precisely. I can actually put it on a robot arm that they made. I come to the regulator. I'm going to apply it to the regulator. It's going to go on top, and you'll hear a little spinning motion. And I'm going to crank it down. No more ergonomic issue. Matter of fact, they load it, start their RFID chip, and they literally walk away. And this is where automation has helped us tremendously with the accuracy. And that's another reason why we like about it. So this thing will actually step down, step up, and dial it in precisely to 103. We can dial it in within a half a pound. And that's amazing. And so I'm going to show you a short video. I'm not going to get too much into it because it's hard to capture everything on video, but we're going to try. So here you have it. You see the control box is in position. Here's the RFID move. Start with a little ring. Now they walk away, literally. It's going to clamp. It's going to come down. And I'm going to start manipulating that regulator. I'm going to dial it down and dial it back up. And then the whole system goes through a test and does a leak and a creep, and we keep all the data. Once again, you want to go with the automation journey, it's fun, stuff like this. But I'm telling you that it was very, very important to have that in-house support. That was great stuff. All right, let's move on. Typical. This is a warehouse. You know, obviously this, it looks pretty empty, but these were brand new racks we just put in. But this is your typical way to control inventory. Remember those companies I told you that we brought in? These are now small integrated parts that go on light axles, things of that sort, a whole different business. And we didn't have anywhere to put it. We're just going to run out of room. Instead of going horizontally, we went vertical. And this thing is called Modula, very, very popular in Europe. Because why it's so popular in Europe? Because they don't have the space. And whoops, I'm trying to see if I can get this next slide. Okay, I apologize. So now we went vertical.
Selecting a tray.
And it also helps us maintain our
storage
inventory. This inventory is a little bit more expensive, and it's kitted, so it can easily walk off and not be handled properly. So we made the investment, and there's 37 trays to this one. This is all based on the height of your factory. So this is at 28 feet, 9 feet across the tray at the poundage. But we're actually going to store these items and recall. You can go as far as to log it in, so when you take something out, it does your inventory counts for you. Once again, why did we do this? Why did we want to do this? Because we thought about it, 4 points, and this helps me reduce the whip and the handling. It helps you control my inventory. So that's a good move for automation. That's me talking about. Just selecting a tray off the diagram. The tray is going to come down. It's going to present itself. The operator will take a part off, obviously, and tell the tray to go back home and go to sleep. It's funny. These are very, very popular in Europe, but you know what else? They're very, very popular. Beer storage and cadaver. sorry to say that, but put you on a tray and put you up, I guess, for restful peace. But then you can see the inventory coming out. Light comes on, it means it's safe to approach it because of the moving parts, and then she sends it back. Okay. This is what you've been waiting for. Our pride and joy. This is our first UR robot that we deployed approximately 5 years ago. And this little robot is going to help us assemble stator assembly. It's got a brass, we call it a stator body, and we've already inserted an O-ring. Okay, that's part of the thing that we've done to prep it. Then we load the tool into the nest, and we also load the sleeve, the stainless steel sleeve, onto the tubing. Now, before we had the robot trying to pick up a tube, insert it in this little sleeve right here. There it is. Okay. And it pick it up. It kept having issues. So we said, heck with it, man. We're just going to load it ourselves. And it worked out very well. Then it's going to actually put it through a press. Now, I should restate something that the robot has to pick up two parts. So his end effectors, which is his fingertips, like his arm with his fingertips, there's like two little grippers. They look like a little crab. And so he's going to pick up the stator tube, as you'll see. And with his other gripper on the same hand, he's going to pick up the stator body from a conveyor. Load the stator body and then load the tubing. It'll make a press, dum dum. It'll do a date stamp, bum bum. You hear that sound? The robot will pick it up, traverse it, and bring it over to the next tool set. Put it in the tool set, complete the press. I'll come back to that in a second because this is something that we learned from the robot. So let's go ahead and watch this. As you can see, and I'll play it again for you. He's going to the first press. There's your clunk. That's your date stamp. He's going to traverse. He's going to load it. And once it kicks it out. Once again, he picked up the tube already. Picked up the stator body. Very fast, I apologize. I'm going to do that. And we'll talk about that because what was so important was, and this is something I'm probably going to get ahead of myself, this thing called collaborative robots, that's the idea. It was years ago that we first were entertained to Baxter. Baxter was a great idea at the time, but it couldn't do it. It couldn't keep the consistency of the same location. It just didn't have the accuracy nor the speed. And a lot of people see collaborative, which can be very good for you, is to pick up and place. That's all it's going to do, pick up and place. Now, there's some people who would challenge me on that, and I understand. But what we had to do is we needed that throughput. And when we first tried the collaborative robot, the idea is that it works alongside an operator without the caging and the safety barriers. Once again, reducing your operating costs. This sounds like a really neat thing, but it just didn't have the throughput. And so we had to speed it up. And we had to speed it up. You bring in safety issues. And there's no way in heck I'm going to run this thing at this speed with this tube and catch somebody in the eye. So we caged it up. We even tried I'll call it a proximity sensor. As you approached the robot, it would start to slow down. The closer you got, the more it would slow down more and more and more because it felt the threat or the danger of hurting somebody. But the problem, there's this constant communication between the robot and the PLCs. It would slow it down. It's just too much information crossing back and forth. So we went with the UR. It's a very simple robot. This robot costs you like 20 grand. Comes with a teach pendant, basically using an iPad. And you can actually maneuver it and test it. Once again, we were very fortunate. Started with St. Philip's College. We sent Dave Roberts, who automatically had the desire to learn and desired to be a robot guy and write the programming. That helped tremendously. And so he set all this up after ITM did the initial. And we started making changes because, once I said, we weren't getting the throughput. I think we were started at 24 seconds, and now we're down to 11. And what was neat about it was when you watch this one step, I know you're like, what the heck? You're throwing that tube around. Let's watch it again. Body, date stamp, going to traverse.
Hey, Mike, I'm not sure if that triggers for everybody in the audience. I would just have them hit the refresh button up on that screen to make it play.
I hope they're seeing it because shame if they don't. But what I'm talking about is right here. Okay, so watching the robot, the things that the robot taught us, You really don't want your robot to be idle. It really needs to be moving. You paid it to move. And it's almost like you're sitting there thinking, come on, robot, move. And what would happen would we notice that the robot would load this tool set, this press, it would back out to a certain position, wait for the press to complete, then it'd go back in, pick it up, and put it in a box. So it would sit there and wait for the automation to complete the press, go back, pick it up, put it in a box. And we thought, you know what? That robot needs to be gone. It's sitting there waiting. And so we said, you know what? We're going to send it. So once we load it, we send the robot on to go start its next process step and let the tool finish itself. And then we have the little flipper arms, flip it out, let it roll into the tub. It's just aluminum tubes, not going to hurt it, and go that route. Saved us 4 seconds, and that's about 600 more parts a day. So once again, I hope you guys are seeing this. Apologize if you can't. There you go. And we'll go to the Q&A and do some other things. And one thing, if this doesn't work for you, if you want to know more about this, give me a holler, reach out through SAMA, give me a call, and we'll bring you in and we'll sit down and let you look at the robot and we'll talk about things. Okay. Go to another one. This is the one that was a little bit more complex, and it's not a big shot, but we take a steel plug and small screw and lower it, and we have to test it, make sure it doesn't move, and we just put a date stamp on it. It's the first time we use a laser. We usually use this concussion stamp, but this is a laser. Laser was new for us. That was kind of a scary part. And what's pretty interesting is we used to laser it on the back because this goes in the spindle, but customers wanted it up front. Here you go with your automation again. You put a lot of money into it. So what's going to happen is you'll see, and we're like, how are we going to do that now? I already got this $25,000 laser that lasers on this side. I had to find a way to flip it. And so once again, it seems kind of primitive and silly, but you'll watch this thing, it'll put it on a device and it'll actually flip it, come down the chute, the robot's going to pick it back up, put it in the laser, pick it up, and put it on the output tray. So once again, let's watch that. And he's working alongside. There's 2 robots. One robot's picking up the plug as it reverses down the conveyor, gets in the proper position. Okay, lets it go through a screw and a drill. And it puts in that screw to calibrate at a proper torque. And then once it meets that requirement, it puts it in a test cube. Actually, it hands it off. The other robot takes it in the test cube. They basically hand off, goes through a test, and then out the door it goes. So let's watch this a little bit. There's the flip. There it goes. See the drill? It's in the center. Let you watch that one more time. Robot 1, Robot 2, UR3 is a little bit smaller. There's your flip. Gonna put it back in the laser right there. Does the laser scan, put the date code, put it on the output, flip 2. And the idea is this robot cell is doing everything. We still have a manual cell. Still got 3 people working over it. And they're doing exactly what this robot do. But once again, I only have to have one person tend this. There's not 3 people involved.
Hey, Mike, can you kind of expand on that? Because we had a question that came in asking about, you still have production needs and you're trying to introduce this automation, how do you do that without destroying
Sure.
Through the end? So
we always had the ability to have an extra tool set. Ever since I've been here, I always have a backup tool set all the time. The young man just came here and said, hey, I got to take it down. He wants to buff it out, and I had a crack piece of steel. We had the other one running already, backing it up. That's what gives us a lot of flexibility to do these things. Even when we do the lean and things of that sort, we're always able to shadow it one way or another so we don't lose that throughput. And the goal is not to have anything done down more than 24 hours. But the key, once again, is very fortunate. We had the old tool sets, which really helps. Never throw your stuff away. And so we could actually subordinate this operation to go into the robotics and good to go. One thing that we've, once again, I said this Friday, we go to review a new T-tester. And what we had to do is we spent $44,000. Okay, that's a big chunk to build me a brand new one. Okay, I still have my other 3 running. And then once we get that one and we run it and it runs well, then we have the flexibility now to go ahead and retrofit the other tools. So go ahead and build a brand new one, get it in place, run it, make sure it's working. What's it going to do? It's going to lower my operating costs and lower my inventory and help my throughput. Then we'll make adjustments on the other three and just retrofit them at a much cheaper cost. Hope that answers your question, but we've had a lot of flexibility on that. I think we're going to go back. That's it. We're going to go back and finish. And just the lessons we learned from the robot. We went through COVID just like you. And the thing I want people to rethink is that, oh, okay, I'm going to go to automation in my plant in case I ever have another virus, COVID-20 comes in instead of 19, COVID-20, the next big bug, and I'll be able to continue to operate. Well, what we learned very quickly, it's not necessarily true. Our vendors are shut down. We don't have customers because they're all went home. The OEMs that we support and we supply and the distributors, they're all closed. So if you think, that automation and robotics is going to get you through the big next bug, I want you to rethink that. There's some things where it can help you because you don't need as many people. I get that, but still really give some thought. Idleness, we talked about it before. Keep that robot running, keep it moving. I'm not a big fan of lights out because it doesn't really make sense that I'm going to load this robot and I'm going to be restricted how much the nesting. You only put 40 pieces on that tube. I can't put 1,000. And if you do that, then you're kind of breaking some of the inventory whip rules from you learn from lean and building a lot of stuff that really has nowhere to go. Or you can take all that stuff and throw it on another operation, or you just create another bottleneck. Simplify, simplify, simplify. When I looked at the tool set with the two robots working together, working the plug, I probably overtasked that. I put too much in there on those robots, and you just don't get the same throughput time. And you made it very complicated. That was one thing I probably shouldn't have done. Another thing that most important that I learned from the robot was watching it prior to the stator. We talked about that tube going across. There's two operations before that. And the robot's in the middle, and then there's robot operation after that. We have to apply a glue, and the glue takes time because you have to cure it. So I'm on the clock, and I noticed that the robot was always pulling from the girls on the left, right? They had to constantly keep loading the robot, or it's going to stop. It'd go to position and hits over like, hey, I need more product, and then it takes that tube out and it dumps it out really quick. So somebody's got to put the glue on really fast. And I noticed that the robot, which could do 2,200 units a day, was actually setting the pace for the entire cell. It was pulling. They felt obligated to keep it loaded. So they're not talking and gibbering like, so they had to keep it running. And the robot never hesitated, and he kept throwing out the parts, the good parts. And so the next person felt obligated to get those parts to the next process step. So that robot running through the plant or running that position just kept that pace. And it was a very balanced pace, and that cell does very well. And it's very consistent because the robot's right in the middle. That's one of the things we learned from the robot.
So Mike, we're right
yes.
at our 12:31, but to the audience, we'd love to have you stay. I think, Mike, you got a one or two more slides, or is this?
This is the last one, pretty much.
Okay.
Once again, it's probably just a lot of you heard me talk about, so we can go through fast. But you got to have that lean champion. You got to have somebody in your organization that has the power, the authority, and the passion to make your move from a standard to automation to semi-automation. Really consider the lean certification course. It's just an eye opener. It gives you the background of everything you need and helps you build that foundation. I'm a big fan of the entire map out your process, which helps you do the Kaizens and you do the continuous improvements, and take that same map and share that vision with everybody in the plant so they can understand where you're going. And always be thinking about speed. Speed is it. When you think of a football team, how do you want to be effective? You want to be fast. And the same thing in manufacturing. The speed always helps me where we didn't used to have a lead time. I could do 300 kits in a day easily, and I could make those orders come in. But now we finally had to go, because now we're doing 600. We had to finally get some lead time on that. I think we went to 2 weeks, and our spare parts inventories out the roof. So rethink speed. Always think about speed. That's one of your key objectives. I want to debunk the myth about change. People say, oh, they don't like change. And the reason why, everybody likes a new pair of shoes. We understand that. but they don't like change when you don't tell them why there's a reason for change, or you don't show them the reason for change. And usually when we make a change as managers, we have engineering over here and we have the actual cell over here, the operators, and there's this huge gap in between, because the engineers expect this to happen on paper, and this is what's actually happening. And your operators get extremely frustrated. You've made a change, and what you need to do is shorten that gap, shorten that expectation gap between the engineering and the operators, and that'll help your change come about much smoothly. Very, very important. And the last one is, when you have the time, lunch, go read the goal. I think it'll help you tremendously. So that fairly wraps everything up. I think.
Hey, Mike, you get your laser pointer.
Yeah, he's focused on the AI.
Yeah.
So here we are now at the last slide, thoughts and questions, and I'm going to turn around, maybe face the audience. I'm going to drop this presentation tool. Oh, they're all gone. Uh-oh. So that's it. Any way I can help you, come by and see me. Anything you want to talk more, more than happy to hear from you. You got any questions or answers? Feel free. Thank you very much.
Great presentation, Mike. Great presentation.
Oh, there goes my lights again. Wow.
Hey, I saw something. Look at that. You're getting claps, Mike.
Can't hear it. Yeah. I'm not going to go bother turning off my lights. Maybe if I just throw something over there, it'll come on.